ST has the highest market share on silicon carbide in the world, quite large. Of course, new competitors are coming. This is normal. Nevertheless, we are investing massively in new capacity with a big fab in Catania, Italy, that we call Silicon Carbide Campus. And in this fab, the most important thing is to make integrated kind of production, means the substrate.
We are at STMicroelectronics India, and we are here and we are going to talk with Maurizio. Now, sir, kindly introduce yourself to our audience.
Hi, Pratibha. It's a pleasure to be here, actually. My name is Maurizio Giudice. I am belonging to STMicroelectronics, taking care about the high voltage silicon division. So I have a long experience in this business, and I'm working in ST since 37 years. So I have a long experience on power transistors, all families of power transistors. So thank you very much for inviting me.
So my first question is very basic but yet important. Super junction structure is well known and is said to be a milestone when we talk about the power devices. So can you shed some light on it?
Yeah, right. Basically, let me say that the super junction is considered a milestone as far as high voltage technology is related. Actually, the introduction of this technology gave us the opportunity to increase the RDS-on per area compared to the previous technology that was planar. So with this multiple drain kind of structure, we industry are able to reach extremely good RDS-on, thermal performances, and basically very nice yield and let me say business growing on this family. Okay, so we are continuing to invest. For example, we have the latest series, the M9 and the K6, that are able to progress the main parameters that are RDS-on per area and shrunk of the silicon.
So industry has seen a major shift from silicon to WBG semiconductors. Yeah, and why there is there's a continued investment in the silicon? Why?
Okay, basically the so-called WBG wide band gap products are silicon carbide and gallium nitride, are both enlarging the TAM of the power transistor thanks to the extremely aggressive performances in switching, in RDS-on per area, and many other parameters that make sure that new applications can be growing. I make an example. The EV car market is taking advantage for the main traction, for example, of the WBG. Nevertheless, the best usage of these new technologies is to increase the performances of new applications. So not only EV, but also industrial and other applications. Nevertheless, the market for power transistor is large, extremely huge. And I have to say that there is a space also for more mature technologies like the superjunction. And in fact, the industry continues to introduce new technology, as we are doing with the M9 and the K6 technologies. And let me say that basically the WBG are increasing the TAM. Okay, so there is a new slice of applications that before could not met with the standard silicon superjunction. So this is the big advantage of having both approach still into the market.
Okay. So what is your, could you please provide an overview of recent advancement in ST power MOSFETs? And can you share some insights of ST superjunction technology roadmap?
Yeah, as I said, there are two series that came out for high voltage and very high voltage that we call M9 and K6. So we are deploying to the market with the new packages tiny dies in order to put more power in a smaller package, as well as using new advanced SMD kind of package. We are also working to have double side cooling, top side cooling, in order to improve the efficiency of the application. On top of this, in our R&D, we are cooking, let me say, new release of new technologies that will improve once again the main parameters. This will work in parallel with the progress of the WBG. Okay.
From ST perspective, how do wide gap band semiconductor influence the current market, and what opportunities do you foresee in this area? As ST has already invested in silicon carbide so much. So
yeah, actually, this is quite an important point, because first of all, ST has the highest market share on silicon carbide in the world, quite large. Of course, new competitors are coming. This is normal. Nevertheless, we are investing massively in new capacity with a big fab in Catania, Italy, that we call Silicon Carbide Campus. And in this fab, the most important thing is to make integrated kind of production, means the substrate construction, that is the most important piece of the silicon carbide, because very expensive, very complicated to produce, and we are starting to produce soon on our fab the substrate. After we make the silicon carbide products, so it means an integration, and there is a plan to extend that fab also for more advanced modules, in order to have a complete integration. So it means substrate, construction of the die, and packaging. Okay. On top of this, we are having an important partnership in China.
okay.
For again another fab of silicon carbide, and this will contribute to keep our market share that today is extremely high, but we will continue in this way, thanks also to new release of technologies, right? As we do with the super junction, that we have many generations, the same thing is happening with the silicon carbide, basically, right? Because new release will come soon.
So what can we expect from ST regarding the gallium nitride fabrication, if I talk about that?
Yeah, I have to say that regarding the WBG, the silicon carbide is much more advanced in-house compared to the gallium nitride, okay? Of course, it's impossible sometimes to have everything in one shot. Nevertheless, we are investing also in the gallium nitride, because we believe that for certain applications and the voltages, the gallium nitride can give a lot of good performances. So, for example, in lower voltage, but also in medium voltage. When we talk about very high voltage, the silicon carbide is really giving the best performances. So, also for gallium nitride, we have let's see, a strong roadmap to come out soon with the products dedicated. We already have some, but we want to increase more for usage in the car, because the car is a kind of lab, okay? So it's a lab, especially the EV, I'm talking about the EV, is a kind of lab where we can experiment for the traction, for the OBC, for the DC-DC, for the battery management system. And for example, we have a lot of business with silicon carbide, IGBTs, and high voltage MOSFET. And the next step can be also the gallium nitride to be introduced.
Great. So my last question is, could you discuss the advancement in technologies with new material and packaging, and how these developments impact the market? And additionally, how does ST plan to address these challenges to maintain its market position?
Okay, the story of the packages is extremely important, because you cannot improve the, let me say, silicon or silicon carbide technologies without going together with packages. Okay, and as I said before, we started to use new packages. Again, able to, number one, dissipate at the best. For example, I have to highlight that the silicon carbide can go at extremely high junction temperature. So in that case, you need the specific packages, but also the silicon, okay? So, as I said before, top side cooling, dual side cooling, and basically we are not concentrated anymore in through-holes packages. Okay, we have huge product range for through-holes, but the SMD, so-called SMD, will get a lot of attention from ST and from the market. On top of this, we have to talk about the power modules. You know, the classical power modules for industrial application, big motor control, they are a little bit bulky and let me say, I don't want to say old, but already mature. Thanks to the EV that needs to have small kind of final application, because otherwise it will be heavier, otherwise there is not much space inside the car. So we are pushing for a lot of package with extremely high performances. Materials to reduce dimensions and the possibility to dissipate as much as possible. This lab, experimental lab that is the car, will give to the industry and also to ST the possibility to export all the, let me say, advanced tricks we are putting in the packages for the EV car, also to the typical industrial kind of applications. So this will reduce the cost, will reduce the weight, and will create a new era of packages able to sustain that kind of performances that the WBG will give.
So one last question I want to ask.
Okay.
So you have been in this industry for so long.
Yeah.
In high voltage.
You see my white hand, right?
Yeah. So what drastic innovation you have seen that it has changed this industry in all your career span?
Okay, let me say that the not considering, okay, the bipolar transistors was, let me say, the first kind of transistor, but with some limitation. Okay, good in current, but not good in switching. Then when the MOSFET arrived, basically there was a big jump, the planar technology. After that, there was the super junction, okay, that we call MD mesh, multiple drain mesh. And in that case, there was another jump in RDS per area, permitting us to have much higher current and very fast switching. Because the current at the beginning of the era was the problem, was not very strong compared to the bipolars. Now we can say that we did a big jump. The next jump, as we said before, is the WR, the WBG, specifically the silicon carbide, that again is improving the thermal performances, the junction temperature, that means you can drive more current for very high temperature, and there is no much difference in terms of change of RDS on, and this is extremely good performance. And then new packages, and not forgetting the gallium nitride for miniaturization of, for example, mobile phone chargers, but not only computer chargers that today are extremely small, and other application I was highlighting before, also in the EV world.
Thank you, sir. Thank you for your time.
It was a pleasure. Thank you for your question and for your time. Appreciate it. Thank you very much.
Thank you, sir.